Okay, here we go. So let's go through this, the Top Hat sign up process. Student sign up. Find your school in the list. So if you start typing it in, you get a list, and you're going to do Arizona State University. Hit next. Okay, so then your name. So Mark, student. Student. So that's my name, Mark, student. Okay, so my email is mark.student at, who knows, mark.com. I'm making it up. Hopefully that's not a real email address. I doubt it. Okay, choose a username. You're going to use your ASU Right ID. Mine is Mashbro1. Mashbro1. Okay, password. Okay, so that's already in use. I've already done this before, so Mashbro10. Okay. Password. Agree with the terms. Okay, for setup grading, you can skip. I will add later. Okay, if you think if you're going to use a mobile phone, or maybe sometimes you use a mobile phone, you can put the number in, and then they'll send you a confirmation code that you will verify. You can do that step. So if you're using a mobile phone, you still have to go through this online, get to a computer, and do this online sign-up process. But I'm going to skip. Okay, then you're going to go down. The last three are my three courses. The second one on the list is what we want. 9, Spring 14, 171, 9. Don't get in 130, get in 9. Okay? Enroll. And that's it. If you get to a screen like this, and you have S14, 171, 9, you made it. You did it. Anybody need assistance? Yes, sir. You can, what's that? You did submit your phone? They didn't send you a text yet? They did or they didn't? Oh, I don't know. Did you put the right number in? Okay, well, you can, what's that? It's okay. You're using the internet, so that would just be for backup that you would have to text. So just for now, you can just use the internet. Any other questions? All right, so let's try. Let's try first questions here. Oh, right. I'm a student at the moment. Like, where are the questions? All right. And some other course-related items quickly. So you should have downloaded the syllabus. Here we are. You guys are the top group there. So again, email is the best way to contact me. My office hours are 11:30 to 1 Tuesdays and Thursdays. 11:30 to 1 Tuesdays and Thursdays. I think is that. So some of you have recitation, but then you can still make that after recitation. Is that right? When is recitation over? 11:20. There you go. So after recitation, you can, if you still need help, come on by. Again, we should have the workbook by now. Course description, goals, you can read through that. Okay, graphing calculator. So you will need a graphing calculator for this course. So most of you have a TI, and that's fine. That's perfect. The Casio is good. The ones that, like a TI 89, perform symbolic algebra, you can't use that on a test. I mean, I can't stop you from using that at home, but on an exam, you won't be able to use that. There are workshops. If you've never used a graphing calculator before, if you're buying one new or you just have limited experience, these workshops would be good to just kind of learn the basics of a graphing calculator. Okay, but if you have a lot of experience, you may find this to not be worth your time. Okay, so if you worked a whole course with a graphing calculator and you know your way around, this probably won't be for you. But if you're kind of new to a graphing calculator, these are good. So is that next week? Next week, Tuesday and Wednesday, 6 p.m. So check that out if you need to. Essential websites, Blackboard, Rational Reasonings where the text is, web work you've already found, and then Top Hat we found this morning. Okay, so there's 4 places on the web that we're going to be using all the time. Okay, this is all just basics. You can read. Oh, so attendance. So attendance is required. 4 absences is the max. There's no excused and unexcused absences. You don't need to bring me, write me emails saying, can I get this absence excused? You have a cushion of 4. That's how it works. You have a cushion of 4, whether excused or unexcused, and then after that you qualify for failure by non-attendance. You also have a cushion of 2 recitation misses. Okay, so you don't need to. I know some of you with official university things going on, you'll bring me notes, and that's fine. But if you overslept or you had a really good reason for missing, it just is one of your 4. Okay, it's just one of your 4. So you don't have to spend both of our times trying to get an excused absence. They don't exist. Okay, homework will be from the workbook and on web work, which you did for today. Okay, there is going to be, we're working on location and hours for a pathways pre-calculus help room. So there may be opportunities for you to get tutoring all around campus. This is the best because we're doing our best to train the tutors in this curriculum, which, as you know, is you're finding out very quickly is really different than maybe some of the math classes you've had in the past. Okay, so we're doing our best to have trained tutors in this curriculum. So this is your best bet for getting help outside of class, next to Chris and myself. Okay, so my office hours and Chris's office hours, that's A+. That's the best help you're going to get. Next best help, close second, will be this Pathways Pre-Calc Help Room. And then getting help from people that aren't familiar with the course is going to be a distant third. Okay, distant third. So, and I will. We don't have the details yet, but when that location and those times get finalized, I'll keep reminding you about that. Okay, so pre-test. Either you took it yesterday or you're taking it today. It's a required element. If you don't take the pre-test, you get a 0 on exam 1. So if you didn't take it yesterday, you got to get to the PSA 21 between 10:30 and 6:30 today. Okay? Bring your Sun card. You don't have to do any preparation, but please do your best. Okay? So if you didn't take the PCA pretest, you are going to PSA 21 today between 10:30 and 6:30 to make sure that you get a grade for exam 1. Okay? And then our first exam is coming up quick in 3 weeks, and then the exams are about 4 or 5 weeks apart. And then we'll have a post-test and a final, which we can talk about as it approaches. Okay, here's the breakdown. 3 exams are 40, final exam's 20. All the homework is 25, and the in-class, top hat, and attendance 15%. The rest is fine print, but you're responsible for it. Okay, last day for open drop ad, I believe, is this Sunday, and then the course withdrawal is April 6th to leave with a W. Any questions on the syllabus? Okay, good enough. What else we got to talk about? We did top hat, we did the syllabus, graphing calculator workshop. Oh, let's just look at Blackboard. I'm going to point out some things on Blackboard. Blackboard. So I've opened up some new areas. So here's the home page again. Homepage will have announcements. Syllabus is the next link. If you want, there's a, you probably none of you will need this, but there's a resource for the in-class questioning system. Most of that you'll learn on the fly. Okay, so I opened up a new area called assignments. And so here's the assignment for today, which was web work, which was due at 8:45 a.m. There was no written homework, and there was no online reading. Those are the 3 components of what you're doing outside of class. Okay, so I've posted what's due for Tuesday. You have another web work. do 8:45 Tuesday morning, and you'll have written homework due on Tuesdays. So there won't be written homework on Thursdays, but there will be written homework due on Tuesdays that you'll write on your own paper and turn it in class. Okay, often a big component of your grade with the written homework will be completeness and professionalism, and good, full, complete sentences when you're explaining. It'll say, explain your reasoning. Okay, and that's kind of the most important thing about the written homework that we can't do as well with the online system is teach you to write about what you're thinking and show and explain your reasoning of why you did certain things. Okay, so the big component of the grade will be, like I said, completeness, professionalism, and good, complete sentences whenever it asks for you to explain your reasoning. Okay, and then eventually we'll get to also including some online readings, which will this will be like pre-class preparation. So it'll be new material that we haven't covered in class yet to get you thinking about what we're about to talk about. But you don't have anything for that for Tuesday. Okay, so every class period there'll be an assignment posted and tell you what the 3 components are. Okay. What else? Class videos. I've posted the class videos area. So every class is recorded on and put up on YouTube. Sometimes it'll be in the middle of the day after class, and other times end of the day, 4 or 5 o'clock. So at the latest, 4 or 5 o'clock of the day of class. Okay? The important thing about this is you need to reinforce what happened in class. And the nice thing about this is you can watch it and pause it and take good notes if you weren't able to take good notes in class because you were really paying attention and really trying to work at it. You can go back now and make a nicer set of notes for yourself, and that's really helpful for reinforcing. But if you just leave class and try to do the homework and that's it, so lots of this stuff that you understood in class will quickly fall out of your brain, okay, with all the other things in your life going on. So this is a reason for these videos. Course websites, office hours. Chris, do you have your office hours yet? No, because you'll be in the center, right? Yeah. Okay, so mine are up there. They're incorrect. I'll have to fix them. Sorry. So mine are Tuesday, Thursday, 11:30 to 1. I'll fix that. And then Chris will get his updated. Any questions about all this administrative stuff? We talked about the calculus workshop. Anything? Yes, ma'am.
So will Top Hat only be used in class?
That's right. Top Hat's strictly in class. Web work is strictly out of class. Yep. Yeah, I won't put any. I think it is possible to do homework on Top. No, it'll just be for in-class questioning. Other questions? Okay, so let's practice with quantities and variables some more. It's really important. We'll be doing this all semester long. So I want you to watch this. Maybe. Let's refresh the page. Nothing. There we go. Lots going on here.
Left.
So we'll watch it a few times, and then what we're going to do is you're going to kind of, amongst yourselves, you're going to be thinking of constant and changing quantities associated with this situation. Specifically, you're going to be thinking of distance and time quantities with constant and changing.
Left.
Okay, so let's So related to this video, we're going to define 6 distance. You're going to get a partner. You're going to find 6 distance quantities and 6 time quantities. So 3 of each. Okay, so 3 constant distance quantities and 3 changing distance quantities. And then for those changing ones, actually define variables. Okay, actually define variables for the changing distance quantities. And then time. Oops. So 3 constant distance, 3 changing distance quantities. 3 constant time quantities, 3 changing time quantities. Okay? So I'm gonna keep showing the video for a couple minutes, okay? So I'm gonna take this off. Everyone got the task? Is it clear? You know what you're doing? Okay, show the video again. Here we go.
Left.
Okay, so you're working with pairs. There should be 20 conversations going on right now. 20 conversations. Find a person.
Here. Left.
Why does it do that?
Here. Left.
No, they're running on a road and through a bridge.
Here. Left.
Why does it do that?
Here.
So 6 distance quantities. 3 constant.
Left.
6 time quantities. 3 constant. 3 changing. Okay, let's see if we can put together a list here from you guys. All right, so first one. Right there. The constant distance quantity. Go for it.
Constant distance from the start of the race to the pit stop.
Okay, so let's be really specific because it's related to the video. So when you say start of the race,
Okay.
so in the
Distance
videos.
from where they started in the video
Okay.
to the pit stop. The pit stop I'm referring to is the people who are on the other side of the bridge.
Okay, so distance. Distance. So ran from beginning of video to the water stop. What do we think? Is that, what do we think about that quantity? How did you do? Yeah.
Make it more specific. Do like distance and we put that in the switch. So we say distance in meters run.
What about in meters? Do we need in meters? No, we don't need, it's just the distance, right? So a quantity is just that characteristic, it's just how far. When we define the variable, we'll need the units, okay? So does it need to be any more specific? I think it does. There's something about this that needs to be more specific. Yeah. No, a quantity doesn't need units. A variable needs units, but a quantity is the characteristic. So it's just like the distance.
How about instead of beginning of the video, you put starting line, distance from the starting line to the water stop?
But there was no starting line in the video. Yeah.
You have to say if it's either the man
Right. So didn't the man and the woman run a different distance? There's two people here. So which one do you want, the man or the woman? Doesn't matter. It was yours. So
Well, you can talk about the man, but I wasn't actually like referring to like runners. I was talking about the distance. But I mean, since we have to do like
it's got to be really specific though, so that someone else reading it knows exactly what distance you're talking about. So
okay, the distance from
because you just said the start of the video, so right, you know what I mean? So
yeah, so you can do that.
yeah. Okay, I think this is good. So the distance the man ran from the beginning of the video. So when it starts the video, the distance he ran from the beginning to the water stop. That's a good one. Okay, another constant distance quantity. Anyone got another one? Yes, ma'am.
The distance both runners ran across the bridge. Different quantities across the bridge.
So which distance? So really, which distance are you thinking of?
From the beginning to the end of the bridge.
Okay, so that's distance. Good, from the beginning to the end of the bridge, or the length of the bridge. Okay, these are two good constant distance quantities. We're going to go on for time's sake. How about a changing distance quantity in this situation? And we're going to actually define the variable. Define the variable. Yes, sir.
distance of the woman from the exit of the bridge.
Okay, so what variable you want to call that? W is the woman's distance from to where?
From the exit of the bridge.
From the bridge exit. What do we think? How do we do? Is it a quantity? What's that? Is it specific enough? I think so. I think that's clear what we're talking about there. And then is there anything else we need? Now we need units. If we're saying W equals, we need units. So what unit do you want? Sure. Is it changing? Her distance from the bridge exit. Yes, this is changing. As we watch the video, that W, that number of meters, will take on different values. Her distance from the end. Okay, that's good. Another one. Yeah, right here in front.
The distance between the woman and the man.
Good. What do you want to call that? M. Distance between the woman and the man. Pick something else.
Inches.
Inches. There you go. How about this? Is it a quantity? Is it a changing quantity, first of all? Is it a changing? Yep. It changes because what she passes him. So that must change. Is it specific enough? Sure, that's just, you're measuring the distance between the two people, and then we've got units. Okay, cool. Good job. All right. How about constant time quantities? Constant time quantities. Volunteer. Yes, sir.
The time elapsed since the man stopped running until he stopped.
Time elapsed from when the man did what?
Stopped running until he stopped.
Started running. To when he stopped running. Is that what you said? Okay, that's valid. The only thing I would say about that is he was running the whole time in the video, right? So he never stopped in the video. That's a totally valid time quantity, but it's a little bit separate from the video, so it's outside the video. But that's okay. That's okay. That's definitely a constant time quantity. How about another one? Yeah.
The time, we'll say the woman was running under the bridge.
The time it took for the woman to run through the bridge. What do you think? Is that specific enough and a constant quantity? Does it work? Yeah, so you could add total. I think it's that's basically the same thing. If we want, we could. But even without total, it still works. Was there another comment on this one? Yeah. The time elapsed since the beginning of the video to when the man did what? Where? Exited?
Yeah.
Sure. Yeah, so the time elapsed from the beginning of the video to when the man exited the bridge. That's a good constant time quantity. Okay, how about changing time quantities with variables? Yeah. Okay, and what do you want to call that?
Changing quantity?
No, what variable?
Seconds?
No, variable. So we're going to define a variable. Like we did up here. We did
S equals seconds.
S.
Cross the bridge.
No, you changed it. Now you're doing a new one. You said S is the time elapsed since the beginning of the video, right? Cool. There was another one up here.
Let's see, T will equal
T equals?
the distance between the rhythm of the woman's gait.
This is a time. We want a time quantity. Yeah, we want a time quantity. So T equals
seconds between footsteps. Is that what changed? Right?
okay. Right. The number of seconds. Okay, actually, let's go back to this first one. Is the first one good?
Units.
Need units, right? If we're defining a variable, we need units. So in seconds. And then T, the number of seconds between steps. How about that? What's that? Oh, yeah.
You're not specifying it's the man or the woman.
Right, we got it. Yeah, so who do you want, man or the woman? Okay. Number of seconds between steps, between the women's steps. And if we were precise enough, that would actually change. You could argue that if she keeps a constant, constant gait, that it's the same. But if we were precise enough, that certainly, it wouldn't be exactly the same amount of time from one step to the next. And so that would change. So that could take on many values of number of seconds. Okay. Any questions? Does this help? Does it make sense? What we're doing here? We're going to. we have to do this all semester long as we're coming into like a problem about a real world situation. And then when things get involved, when you start working with these building expressions and solving, and you get to the end of the problem, it's really crucial that you've defined it well at the beginning, so that when you get to the end of the problem and you get some kind of answer, you know what that answer means, and that answer will then be related to how you defined that variable. If you don't define the variable, or if it's vague, and then you get an answer at the end, then you'll have a tough time really nailing down what do you mean by that number. And we're going to be all about that. When we get numbers for answers and we're working with numbers and expressions, we're going to be all about what's the meaning of that? What does it represent? Okay. Any other questions? All right, so that was good. So what's next? All right, so we want to talk about the change in a quantity. So I've defined here down at the bottom of the screen, I've defined Z as the amount of rainfall in Tempe since August 1 in centimeters. How did I do defining the variable Z? Did I do okay? What are the criteria? It's got to be a quantity, first of all. Is it a quantity? Yep, amount of rainfall. They measure amount of rainfall. Okay, is it specific enough? Certainly, okay? Does it have units? Those are our three criteria, so we got a good one there. So I want to show you a representation. Gee whiz. Here we go. So here's a representation of that variable Z. We said so that variable Z represents all the different values that quantity can take on. It represents all the different values that quantity can take on. So how does this red bar represent the variable, or the quantity that we're representing by Z? How does this red bar represent the quantity that we're calling Z? Jonathan?
It's the total amount of rainfall since August 1st.
Okay. And so how would you interpret what you're seeing right now?
It's every possible value since August 1st.
Okay.
I would say that we've had 6 centimeters of rainfall in Tempe since August 1st.
Right. So that red bar is showing that the current value of Z, which is 6 centimeters, and then I can change that. So we can say 3.5. So this is showing now the value of Z is 3.5, meaning there's been 3.5 centimeters of rainfall. Okay, or 8 centimeters. Okay, so now here's something else. Then what might this represent? The blue bar. So what does the blue bar represent? If the red bar is showing that since August 1st, we had 8 centimeters of rain, it's the current value of Z, then what does the blue bar show? What's that? Oh, I'm just asking you to guess. So what's that? No, so it's still on the scale for Z, right? This is the Z scale. This is the value, this is the quantity Z, the amount of rainfall. It's not a new quantity. So what does that blue bar represent relative to the quantity Z? Yeah. Which change? Can you be more specific?
Since August 1st.
Okay, can you be more specific than that? Okay, sorry, I don't have this on yet. Okay, sorry about that. So where were we here? Okay, there we go. And now I should be able to draw. Right, okay. So we said the change. No, it's not a new quantity. We're talking only about this quantity. It's just this quantity, yeah.
The amount of rainfall in Tempe since August 1st.
It's not. We only got this one quantity. It's not. Don't change. It's not a. It's not. This is still the amount of rainfall. Yeah. Okay. So on the scale, what is this right here? Yeah, maybe 1.4 centimeters is the start of that blue bar, 1.4 centimeters. And what's the end here? 5.4 centimeters. So that blue bar represents,
The increase in rainfall from 1.4 centimeters to 5.4.
yeah, so it's the change, the blue bar represents the change in Z. The change in Z starting at 1.4, from 1.4 to 5.4. And what is that amount of change? 4 centimeters. So like you said, that's like an increase in the amount of rainfall. At some point after August 1st, we had reached 1.4 centimeters. And then over time, as it kept raining, then at another point, we reached 5.4. And so that blue bar represents the change in the amount of rainfall from 1.4 to 5.4 centimeters. Because after all, by defining this quantity as a variable, we're saying it's a changing quantity, right? We're saying it's a changing quantity. So we're highlighting this particular change in that quantity. We're saying start at 1.4 and end at 5.4 centimeters, and we're going to specify that's the change in the quantity. And so let's do another. So that's 4 centimeters. 4 centimeters of increase. So let's, okay, so tell the person next to you, what does that represent? The blue bar, now what does it represent? Go, what does that represent? Okay, how would you describe what the blue bar is showing now? How about you right here? Somebody new. Yeah. Yeah. Exactly the same thing? Well, so can you be more specific? What? So tell me, what are we saying here? Yeah. The change in Z starting at 4 centimeters and ending at 8 centimeters. And what is that change in Z? It's still a change of 4, but it's a different change in 4. See? It's a change in 4 that starts at 4 centimeters and ends at 8 centimeters. Okay, so now I'm going to tell you that this change starts at 3.72 and ends at 6.18. What's the change in the amount of rainfall? What's the change in the amount of rainfall that I'm showing with the blue bar? How did you get that? What? You just counted. Wow, I can't do that. Yeah. Take 6.18 and? And what is it? What do you get? Yeah, so now 4 was easy just to see. You didn't even have to think about it, right? You just saw that the length of the bar was 4. But now when the numbers get a little hairier, how are you going to get that actual change? Well, you got to take the final value, subtract the initial value, and that gives you that amount of change. So this is showing a change in amount of rainfall starting at 3.72 centimeters and ending at 6.18, which is a change of 2.46. And so the notation we use for that, when we're talking about the change in a quantity, is we use delta, uppercase Greek delta. That means the change in, and then whatever quantity you're talking about. So that's like a new quantity. So Z is the amount of rainfall. It's just the value of the quantity. And then delta Z is a new quantity that we get from it. So it's a change in Z. And that same change of 2.46, we could look at it from the beginning. So there's that same amount of change, but now starting from 0. There's the same amount of change, 2.46, but starting at 0 inches or centimeters. Okay, so like we said, this whole course is about changing quantities, and so this is our representation for the change in a quantity. The change in a quantity. We use delta Z. Anybody have a question? Does it make sense? Cool. Okay, so let's do this. Okay, so the setup here is we've got we're gonna whip up a really good chicken dish, okay, for a big date we got coming up this weekend. So we got to go to the store and get some chicken, and the chicken costs $3 a pound. It costs $3 a pound in the store, okay. So I'm gonna come along here and I'm gonna say, first of all, how have I done defining my variables? X is the total weight of chicken in pounds. Y is the cost of the chicken in dollars. How did I do defining those variables? Did I meet all the criteria? Awesome. Okay, so I'm going to buy 1 pound of chicken. How much is it going to cost? If you're listening, $3. And when I do that, I've got this graph down here, and this is my number of pounds here on the horizontal axis, and the vertical axis is the cost. So when I put in 1 pound, it gave me $3. I got this point. What does that point represent? So when you look at that point on this graph, it has a meaning. What's the meaning of that point? Yeah, so that actually is, that 1 point, that visual 1 point actually is kind of like 2 pieces of information taken together, right? It's the simultaneous values of these 2 quantities. And so it's the 0.13. The 0.13. So that point, when you look at that point, it's the simultaneous values of 2 quantities taken together. Okay? So then I'm going to come along here and do, say, what was it? So 7 pounds. How much is it going to cost? 21. Okay, so now no longer is, that's now this, now here our 1.3 is down here, and here's our 7.21. So we got 2 points. How about 2? No, 3. How much will 3 pounds cost? 9. Another point. How many possibilities are there for amount of chicken we can buy and the corresponding cost? Just a couple more? There's lots, right? So I'm going to go ahead and make a point for all these different pounds and corresponding costs. And what happened? So here's now all these, grabbed all these points, and if I zoom out on this thing, what do you see? Okay, see a straight, so you see a line, and so what you see is a graph, okay? And so you're used to seeing graphs in the past, and so when you look at a graph, what is it? What does it consist of? What is it about? Any graph. Could be curved, could be a line, doesn't matter. But what does it consist of? Okay, that's what it represents, but what does it consist of? What is it made of? Okay, so you're all talking about what it's representing. What I'm getting at is any graph, when you see a curve or a line. Okay, points. Right, points. Yeah, So when you see a curve or a graph or a line, your image of it should be many, many, many points. Each one of those points then is the values of two quantities simultaneously taken together. In this case, it's pounds and cost. So each one of these points represents a certain weight and the corresponding certain cost. Okay, so I'm going to take these off and let's just figure that out. All right, and let's do 12. And 12 pounds costs how much? 36. All right, and then I can okay, so now we got this graph. How many points does that graph consist of? How many points does that graph? So this black line. How many points am I showing on that black line? 5? I'm showing 5 points on that black line. How many are there? What's that? He wants an infinite. Is it 5 or is it an infinite number of points on that black line?
5.
Infinite. When you look at a graph, whether it's a curve or a line, what does it consist of? Lots and lots and lots of points. That I'm trying to change your image of when you see a graph in the newspaper or in a magazine or in a textbook or all the stuff you'll be doing for an engineering. There'll be lots of graphs. What that really is, in its true essence, is many, many, many points. So this is not 5 points here. This black line that I drew is many points. It's every possible number of pounds and its associated cost. So when you look at a graph, you need to have this image of, oh, I'm looking at a bunch of points. It would take too long to draw it that way, you see? It would take too long to do it what it actually is. So we do the quick version, but we know what it means, right? So the quick version is a line or a curve. But the meaning of it is many, many points. Okay, so now let's talk about changes. So we can have changes in the weight, and we can have changes in the cost. All right, so we're going to say x changes from, say, 1, 2, 3. X changes from y, 1 to 3. Okay, and so what is delta x? What is the change in the weight? 2. So it's kind of like there was a pound of chicken on the scale, and he said, oh no, wait, I need more. And so please put 2 more pounds on the scale. So the butcher goes and he takes 2 more pounds and he throws it on the scale. That's like a change in x, right? The change in weight. And so that is 2. Okay, when x changes from 1 to 3, how does y change from what to what? I don't know why that is. Yeah, it should be 2. Okay, so delta x changes from 1 to 3. Let's make this bigger. Distance. Yeah, there we go. All right. So when x changes from 1 to 3, the delta x is 2. When y change, then if x changes from 1 to 3, then the change in y is fixed. It's got to change from 3 to what? Is anybody paying attention to the mistakes that are coming up on the screen? Okay. If I make mistakes, please tell me before we dig a hole for ourselves. Okay. I'm going to make some mistakes. Don't hesitate to say, hey, I don't think that's right. Okay. And we'll hammer it out. All right. So then, what's the change in y, or what's the change in cost? 6. Okay, so now how would we show these changes on the graph?
Already there. It's on the line.
What's that?
It's already there on the line.
If I just want to show the change in x from 1 to 3, how can I represent the change in x from 1 to 3 on this graph? Just the change in x. What kind of line? It'll be a horizontal line, right? Starting 1 on this axis or the up and down axis? Yeah, on the x-axis. And finishing at? Okay, or I could start at that point for the 1, 3. I could do it here. Either way. So right there, do you see that that bar is representing delta x equals 2 starting at x equals 1, or the change in x starting at 1, okay? And then? So this is delta x and equals 2. Is that the only place we could have delta x of 2? No, we could start at 8 pounds and have a change in x of 2. We could start at 0 pounds and have a change in x of 2. It's just this was the specific one where x was changing from 1 pound to 3 pounds. Okay, cool. And then what do we found? We found the corresponding change in y was from 3 up to 9. And that was a delta y of what? 6. So we're using the graph and we're representing these changes. When x changed by 2, y changed by 6. Or when the number of pounds increased 2 pounds, our cost went up $6. Okay, so what I want you to do is I want you to use these values to come up with some more lines in my table. Okay, you guys are going to just take a couple minutes, maybe make up 2 or 3 more. So only using these values or the points that I've plotted, come up with some more changes in x and the corresponding changes in y. So it's like you're creating some new rows, and you all will have something different. Okay, so you're going to create some new rows here in that table. Go. Okay, so how about somebody over here? You're there. So what'd you get? X changes from what to what?
Got an x change of 3 to 12.
3.
Change of 9.
Let's do 3 to 12. Okay, and so when x changes from 3 to 12, what is delta x? Somebody over here. X changes from 3 to 12.
9.
9. Okay, this is just not working. Let's do this. Contents. Okay. And we'll make it all. Okay, so 3 to 12 means a delta x of 9. And as x changed from 3 to 12, or as our pounds changed from 3 to 12, what does our cost change from? Tell me. From what to what? What's the cost change from when the number of pounds changed from 3 to 12? So x started at 3 and ended at 12. That's the pounds. So our cost will change from 9 to 36. Okay? And what is that change in the cost? 27. It's how much our amount went up from 9 to 36, 27. And so let's represent that on the graph. So I'll do that in red. So in red, here we are at 3. A change in x of the best line I've drawn all day. That's a delta x of what? 9. Resulting, as a result of that change in x, the cost went up how much? 27. Okay? All right, I'm going to do one. How about this? Seven to 3. Can you do it? Does it make sense? What would it mean, and what would that mean? What would x changing from 7 to 3 mean in this situation? If you, so how many pounds were on the scale? 7. And so what was the change in the number of pounds? So we need a way to represent decrease, and so naturally that would be negative. So the change in x is negative 4. Okay, so we started at 7. We'll do this in blue now. This third one. Started at 7. And now delta x is, so your delta x comes first. Negative 4. So I started at 7 and went down to 3, or in other words, reduced x by 4. What does y change from when I do that? 21 to 9, which is a change in y of? So what did we say to calculate the change? It's what? Final minus initial. So what's 9? So we do 9 minus 21. Is it 12? Negative 12. Negative 12. Okay, and so then that is shown by going down $12. If you take 4 pounds off the scale, you're going to pay $12 less. That's what we're saying. And so this is how we're representing that. When a quantity decreases, the change is negative. And that works out with the math. Take the final value minus the initial value, you're going to get a negative result. Okay? So in all these, how is delta x and delta y related? It works for all of them here. So this was what? Delta x was 2. And the resulting delta y was 6. When delta x was 9, delta y was 27. When delta x was negative 4, delta y was negative 12. So how can you always, in this situation, calculate delta y? What is it? 3 delta x, right? However much you change the number of pounds by, your cost is going to change 3 times as much as that. However you change the number of pounds by, your cost is going to change 3 times as much as that. Okay? If this is always true as x and y change together, then we have what's called constant rate of change. So if this is always true, then we have what's called constant rate of change. So now within a day here, now we're really starting to talk about how quantities change together. So what did we say? This course is about quantities. And then we said it's about changing quantities. Well, then we take it a step further. This whole course is about how quantities change together. How quantities change together. And so this is all this analysis we're doing is we're looking as the number of pounds changes, how does the cost change? There's a special relationship here. The change in cost is always 3 times however we change the weight of the chicken. And if that always holds, that's constant rate of change. Okay? And so what we really have here is we have proportionality of the changes. So constant rate of change means I guess I could just type. Constant rate of change means that the changes are proportional. The changes are proportional. And we did proportionality problems growing up. What did you do to solve those problems? What was the proportionality problems? What were those like? Remember that? Proportions, doing proportions. What were those like? Yeah. Right, we said equal ratios. So looking at our relationship over here, what ratio is always maintained? If delta y equals 3 delta x, then what ratio is always the same? So, what's that?
3 to 1.
Yeah, so what ratio is that? 3 to 1 would be the ratio of what to what? What's that?
Y to x.
Y to x, is that right? Is it the ratio of y to x? Close, almost. Delta y to delta x. Okay, so delta y over delta x. If we look, first we had 6 and 2, right? If delta x was 2, y was 6. If delta x was 9, y was 27. If delta x was negative 4, y was negative 12. So we're looking at all these implications for the mathematics of constant rate of change. The first implication is that the change in y will always be a constant multiple of the change in x. In this case, that constant multiple is 3. Why? Because the chicken was $3 a pound. So any additional amount of chicken or a reduction in chicken will mean 3 times the increase in cost or the reduction in cost. And so that also means that the change in y to the change in x is this constant ratio of 3. Those are in a constant ratio, okay? And then there's one more thing. So what we're doing is we're establishing kind of the three different ways to look at constant rate of change, okay? That delta y is always a constant times delta x, that you always create a constant ratio, and then the third one is this. What happened to my graph? Oh. We're back. Okay, so the third one is this. If I increase by say if I increase by 3. If delta x is 3, then what's delta y? 9. And up here, if delta x is 3, what's delta y? What's delta y now? Still 9, right? Still 9. Every time up here, if I go from 12 to 15, How much will my cost go up if my pounds goes from 12 to 15, or delta 3 equals 3? Delta x equals 3. 9. So here's the third implication of constant rate of change. Equal changes in one quantity result in a consistent change in the other. So every time we load up 3 more pounds on the scale, that's going to make our cost go up 9. Every time we load up a half a pound more on the scale, delta x is a half. How much will my cost go up? $1.50. No, a half a pound. Every time I load up a half a pound more, no matter how many pounds are already on the scale, if I make delta x a half, then my change in cost is going to be $1.50. Okay, so let's summarize what we just talked about. Maybe. Okay, constant rate of change. 2 quantities vary together at a constant rate if, first possibility, equal changes in one quantity result in consistent changes of the other. That was the last thing we talked about. Every time you add 10 pounds to the scale, your cost is going to go up $30. The change in one quantity is a constant multiple of the corresponding change in the other. And that was when we said, hi, I have 10:15. And yeah, so I'll make you a deal. How about, can you give me till 10:20, and then I'll be cleared out, and you can have 10 minutes to get ready? Thank you. Thank you. Yeah. This is what we said, right? And then, last one, corresponding changes in the 2 quantities maintain a constant ratio. So we said, I give her 5 minutes and she gives me 10. Or I give her 10 and she gives me 5. It's fair, right? More than fair. Okay. So this is really important. We're going to be talking about it again Tuesday. Your homework is about it. So as you're doing your homework, keep relating the questions that are being asked to this. Constant rate of change means that equal changes in one quantity result in a consistent change in the other. The change in one quantity is always a constant multiple times the change in the other. And the proportion of those 2 changes maintains an equal amount. So maintains a constant ratio. Okay, so you got your work for Tuesday. Have a great weekend.